welcome back again. I'm your instructor, Amy Flicksteiner, and this is elementary algebra. Sorry for the little snaps there. We are currently going to be looking at section 7.5, which has just two goals in it. We want you to be able to simplify complex fractions using a division process and also a second tool for your tool belt, which is to be able to simplify complex fractions using the lowest common denominator. To begin with, we're going to talk for a few minutes about what a complex fraction is. A complex fraction is a fraction within a fraction. Basically, you have a very large numerator in denominator, and within the numerator, you have several fractions, well, one or more. And also within the denominator, you have one or more fractions. This makes it complex. You may have done complex fractions previously with numbers. An example of a complex fraction with just numbers, I'm going to make this up on the spot, so I'm not sure how it's going to go, would be something like 1/3 plus 4/5 over, see how that's just a big old little fraction, over, and maybe you had something like 4.5 minus 3.1/3, right? And so basically, if you had a problem like this, maybe in a pre-algebra type course, what you would do is find a common denominator here. You would rewrite this as 5/15 plus 12/15 and get 17/15 there. And then you would do the fraction in the denominator. So let's see, 4.3/6 minus 3.2/6 would be 1.1/6, right? And then you would take this guy and we would do 17/15 divided by 1.1/6, which is 17/15 times, we have to convert that to 7/6 times 6/7. Then ideally we cancel, that's a 2, that's a 5, and we get 34/35. Yes, that's what it would look like longhand in numbers. And that's exactly what we're going to do. We're going to do that, but we're going to do it with variables. So, 4 main stages or steps that we run through. The first is to simplify the numerator in one, we're going to what do I want to say? We want to simplify the numerator and the denominator. So we're going to individually simplify the numerator. We're going to individually simplify the denominator. Simplify the numerator in the fraction down to one fraction, like we got 1/4 plus 4/5 to 17/15. Then we're going to do the same thing for the denominator. We are going to actually do the operation that's listed there, and we're going to get 1.1/6. The preference being an improper fraction. That works better. Once we know what those two are, we will divide using multiplication by the reciprocal. That's exactly what we did. And then we're going to simplify what we can. All right? So what does that look like? Well, here we go. We have 5x squared over 3 over 7x over 15. Is the numerator as simplified as it can be? We're going to simplify the numerator to one fraction. Yes, it is. 5x squared over 3 is one fraction. We're going to simplify the denominator to one fraction. Yes, 7x over 15 is one fraction. We're going to rewrite this as division. So this is 5x squared over 3 divided by, that will stay exactly the same, 7x over 15, right? Now, we're going to use the idea that multiplication is, or that division is multiplication by the reciprocal. We're going to keep the first one. We're going to change the division to multiplication and flip the second one. 15 over 7x. Looking at these two, is there anything that we can cancel? I do see things that can be canceled. I see the 3 goes into 3 once and the 3 goes into 15 5 times. So I can cancel at that step. I also see that x goes into x squared, leaving me with just a single x. Now I can multiply across. 5 times x times 5 is 25x. 1 times 7 times 1 is 7. So this is 25x over 7. And that's it. 25x over 7. I've simplified it. All right, let's try another one. Okay, that went better than I thought. 4 basic steps. Simplify your numerator, simplify your denominator, divide using multiplication by the reciprocal, and then go ahead and simplify what you can. Sorry, my fingers here. Okay. All right, so let's try this one. Oh, brothers. Okay, so this is going to be d over 5 minus 3 over d over 1/3 plus 2 over d. Okay, so let's just concentrate on the numerator. I have denominators of 5 and d. So if I look at d, that's over 5. So this will be d times d minus, that's 3 over d, so that'll be 3 times 5. So that's going to be d squared minus 15 over 5d. I have simplified my numerator. Now I need to simplify my denominator. My denominator is 1/3 plus 2d. So that's going to give me a denominator of 3d. Numerator is 1. It's over 3. It's missing the d. So that's going to be 1d plus 2. 2 is over d, but it's missing the 3. That's 3. So that's going to give me a d plus 6 over 3d. Now I need to rewrite this as division. So this is going to be d squared minus 15 over 5d divided by d, exactly as it is, d plus 6 over 3d, which is keep d squared minus 15 over 5d, change your division to multiplication, and flip 3d over d plus 6. Once I've done that, I want to look to see if I can cancel anything. I think I can just cancel the d's, right? That d and that d. Numerator, denominator. I don't see anything else. So this will be a 3d squared minus 15 over 5d plus 6. Nothing else is going to cancel. I can't, the d squared, that's squared, but 15 isn't a square. So I can't factor that any further. D plus 6, yep, done. Okay. All right, that one's good. Let's try the next one. I have 4 over x plus y. I'm going to write that as y over 1 so that I have those denominators there. And then my other one would be x over 1 minus 3 over y. So let's concentrate on the numerator and let's make that into one fraction. So with denominators of x and 1, the only denominator I need here is an x. It's already a 4 over x, so that's not going to change. The y is over 1, so I'll need to multiply the y by x, so that'll be xy. Can I simplify that any further? 4 plus xy over x? I cannot. So this is it for that guy. What about this one? This one would need a denominator of y. That would be xy minus 3, because I can't, that's already over y, that's good. Okay, now 4 plus xy over x divided by, yep, we want to write this as division. 4 plus xy over x divided by xy minus 3 over y. Change your division to multiplication. So we're going to keep, change division to multiplication, and we're going to flip y over xy minus 3. I might just change this to a dot, because otherwise it looks like too many x's. Yeah. All right. Will anything cancel? Nothing's canceling. That y won't cancel with x. A 4xy, 4 plus xy, xy minus, these aren't exactly the same, so I can't cancel. I cannot just cancel partials, because these would be in parentheses as with this. So they have to be exactly the same. They're different factors. So this would be y times 4 plus xy over x times xy minus 3. Nothing else cancels. This is as much as I can do. All right. Fantastic. I love it when a plan comes together. All right, what about number 4? We're going to concentrate on the numerator first. 1 over c plus 5/4. That's good. 2 minus c squared. All right. So if I need to combine these, I need a common denominator of 4c. The 4 and the c has a common denominator of 4c. So this would be 1 times the 4 plus 5. That's only over the 4, so I need to multiply that by a c. All right, simplify it. I get 4 plus 5c over 4c. The denominator is 2 over c squared. That's already one fraction. I don't need to, okay, so this is not, that's just going to be 2 over c squared. So we're going to rewrite that as division. 4 plus 5c over 4c divided by 2 over c squared. Exactly the same. Now I'm going to change division to multiplication. 4 plus 5c over 4c times, I'm going to use the reciprocal, c squared over 2. Can I cancel anything? I see some canceling. This c will cancel with the c squared, leaving just a c. And then I have here a c over us. Oh, that should be a 2. Good Lord, I'm glad that should be a 2. Glad I caught that. Okay, I was going to say, why would that cancel? That's a 2. C and 2 doesn't cancel. Does the 2 cancel? I can't cancel the 2 with that 4, and I can't cancel the 2 with the 4 plus 5c, because that's like all together. So I think I have c, 4 plus 5c, over 4 times 2 is 8. And I think that's as much as I can do. Right? I mean, I could write this as 4c plus 5c squared over 8. That would be an okay answer too. But like I said in a previous video, my preference is to see the factors, because then when I look back at it, I'm certain that I couldn't cancel anything further. So I prefer a final answer in factor form, but you just got to watch what they're asking for, because maybe they do want you to multiply it out. Sometimes, not all the time, but sometimes. Right? That's the first method. And that's a beautiful method. It's not my favorite. We're coming up on my favorite. So this second method, which uses the LCD, is my favorite method. And you know this is my favorite method because anytime we can use the lowest common denominator to make things simplify faster, I am so on board. I am on board with efficient methods, right? So there's still 4 steps, but it's so much, I think it's so much simpler. Maybe it's not for you. That's why we're giving you 2 options here. So first thing we're going to do is we're going to look at the complex fraction, and we're going to find the lowest common denominator for all of the fractions, for the entire complex form. So if we include all of the little denominators in here, what is your lowest common denominator? We're going to multiply the top and the bottom of your largest fraction by that LCD, because the lowest common denominator over itself is a representation of 1. So basically, we're about to change the look of the fraction without actually changing the value of the fraction. Then we're going to perform the multiplication to the numerator and the denominator. And when we're done, we should no longer have a fraction within a fraction. We'll still have a fraction, but we won't have a fraction within the fraction. We'll check the remaining factors to make sure that we don't need to simplify anything, that there aren't any further common factors that can be reduced. All right? So let's get on this. Now, problem number 5. Notice our denominators. I'm going to maybe do a color here. I'll do the yellow. Well, yeah, we'll do the yellow. I have internal denominators of x, 7, 2, and x, right? So if I look just at the numerator, the lowest common denominator is the first denominator, x, times the second denominator, 7, especially if it's not included. If these are not the same, you have to include both of them. The next denominator we're looking at is 2. It was not included in the others. And the fourth denominator here is x, but it was already included, so we don't need to do it again. We're just going to leave it, right? This makes our lowest common denominator 14x. So what do? We take 1x minus 1/7 over x over 2 plus 1 over x. And we multiply both the top and the bottom by 14x. This works because 14x divided by 14x is the same as 1. We are effectively multiplying this fraction by 1. And when we do that, we will change the look of things, but we will not change the value. I sometimes say it's like when your mother calls you by 3 names. You know you're in trouble. She hasn't changed your internal value, but she's told you something about how she's feeling, right? Somehow you got into trouble. So we're going to do the same thing here. This is going to equal 14x times 1 over x minus 1 over 7 over 14x times x over 2 plus 1 over x. Now, we're going to distribute that 14x. I'm going to show an intermediate step. Many of you will not need to show this part, not internally, but I'm going to show it so that you see what we're doing, for those of you who are unfamiliar with this. So I'm going to do 14x times 1 over x. That's going to give me 14x over x. And I'm going to subtract the 14x over 7. I'm going to do the same thing with the denominator. So I'm going to have 14x squared over 2 plus 14x over x. Why would I do this? Because here I can cancel things. The x's cancel. The 14 and the 7 cancel, leaving me a 2. The 14 and the 2 cancel, leaving me a 7. And the x's cancel, leaving a 14. This gives us 14 minus 2x over 7x squared plus 14. Do you see how I've eliminated sort of the double denominator now? Now I just have a numerator and a denominator. From this point, I will probably factor out a 2 here. And here I would factor out a 7. Once these are factored, I notice that nothing will cancel. The 2 doesn't cancel with the 7. The 7 minus x won't cancel with the x squared plus 2. So this is it. I can't do anything more, and I'm done. Right? Okay. Some people don't need to show really either of these 2 steps. Once you get good at this, you can go from here to here. Let's try another one. Problem number 6. We have m minus 1 over 2m plus 1. There's a denominator within, and 1 minus m over 2m plus 1. My least common denominator is indeed the 2m plus 1. There's no other denominators. I could put them over 1, I suppose, if I write it that way. Right? I could have m over 1 minus 1 over 2m plus 1. And I can have 1 over 1 minus m over 2m plus 1. I'm going to multiply 2m plus 1 over 2m plus 1, because this is the same as multiplying by 1. I'm just making a really big number 1 here. I don't know if you can see my number 1 there, but I'm making a really big number 1. I'm just being a little goofy. Okay. So what is that going to be? Well, without writing everything out, I have 2m plus 1 times m. All of this over 1 minus 2m plus 1 over the 2m plus 1 that was already there. Right? In my denominator, I'll have a 2m plus 1 times 1 over 1 minus m times 2m plus 1 over 2m plus 1. I could put these guys in parentheses if I wanted. Now, when I go ahead and cancel, what I can, on this guy, nothing will cancel. On the first one here, that's just going to be 2m plus 1 times m. And then over here, both of those are going to cancel. That's just going to leave me with a 1. So that's going to be minus 1. In the denominator, I have 2m plus 1. Okay, so that's just going to be 2m plus 1 minus the 2m. So that's going to be minus m. 2m squared plus m minus 1 over m plus 1. Oh, I hate when this happens. Okay, I fixed it. I hate when it stalls like that, especially when I'm engrossed in writing it down. Okay. I can't remember where it jumped to, but I was canceling. 2m plus 1 cancels out, leaving me with a 1. So this 2m plus 1 times m is repeated over here. Over 1 doesn't make any difference. Minus 1. And then the 2m plus 1 over 1 is just a 2m plus 1. Minus, here the 2m plus 1 cancel, leaving me with just an m. Simplifying, I have 2m squared plus m minus 1 over 2m plus 1 minus an m, which is just going to leave me with an m plus 1. This is a lot of noise. Okay, so now what I need to determine is if this will factor. Will 2m squared plus m minus 1, is that factorable? Okay. Is it factorable? Hopefully you're recognizing how big of a deal factoring is. All right, so I want to take 2 times a negative 1, which is negative 2. First times the third, a times c. So what factors of negative 2 will break down and add to a positive 1? So that's a positive 2 and a negative 1. So this would be 2m squared plus 2m minus m minus 1. I can pull out a 2m, and I'm left with m plus 1. Now here I can't pull anything out, but there is a lead negative. So I'm going to pull out a negative 1, and that's going to leave me with m plus 1. Now the m plus 1 will be out front, and I'm left with 2m minus 1. Okay, so what that tells me is that, yes, this is factorable. So there are my factors. This will factor into 2m minus 1, m plus 1, over m plus 1. Will anything cancel? For the first time in today, yep, that m plus 1 is the same in both the numerator and denominator, which means it will cancel out, giving me a final answer of 2m minus 1. So this entire complex fraction, which was 2m plus 1, when simplified, becomes 2m minus 1. Beauty. Okay. All right, let's try 7. Okay, looking at all of the denominators. We have a w plus 2 and a w plus 3 and a w. So my least common denominator is going to be that w plus 2 times the w. I have not yet included a w plus 3, so I need to include the w plus 3 times a w, but w is already there, so I don't need to do that. So our least common denominator is going to be a w times a w plus 2 times a w plus 3. So I'm going to have 1 over w plus 2 plus 1 over w over 6 over w plus 3 minus 3 over w. I'm going to multiply both the top and the bottom. Multiply it by a w plus 2, w minus 3 over w plus 2, w minus 3. Okay. Oops. Close that out. What's that going to equal? Okay, so if I multiply all of this by the first term, it's the w plus 2 that will cancel, right? All of this times that first term, it's the w plus 2 that will cancel out. That's going to leave me with a w times w minus 3. Now, if I take all of this and multiply it by the second term, it's the w that will cancel out. So that's going to leave me with a plus w plus 2, w minus 3. Similar things will occur in the denominator. In the denominator, I have a 6 over w plus 3. So it will be the w plus 3 that cancels out, leaving me a 6w, w plus 2. Then I have a minus, and then I have the w again that will cancel out. But this time there is a 3 in front. So it'll be minus 3, w plus 2, w minus 3. All righty, let's do some simplifying. W times w minus 3 is w squared minus 3w. Now I've got a w plus 2, w minus 3. That's going to be a w squared plus 3w, or minus 3w plus 2w, minus w, plus 2 minus 6, minus 3 is a negative 6. That's going to be my numerator. In my denominator, I have a 6w squared plus 12w. All right, that's going to be, that's going to be the w squared minus w minus 6 times a negative 3. So I'm going to have a minus 3w squared plus 3w minus 3 times a minus 6 be a plus 18. Okay, still simplifying the top. I've got a 2w squared minus 4w's minus 6, okay, over 6w squared minus 3w squareds plus, is it going to be 15w? Plus 15w plus 18. Okay, now we got to look at this guy. Can I factor? Sure, I can take a 2 out. And I'm left with w squared minus 2w minus 3. Here I can take a 3 out. And I'm left with a w squared plus 5w plus 6. Okay. Can I factor w squared minus 2w minus 3? I can. This is a 2. W squared minus 2w minus 3 multiplies to give me a negative 3, adds to give me a negative 2. So that's going to be a w minus 3, w plus 1. This one, can I factor a w squared plus 5w plus 6? I can. That factors, multiplies to give me a positive 6, adds to give me a positive 5. That's w plus 3, w plus 2. Okay. Does anything factor? Does anything cancel? Nope. W minus 3 will not cancel with w plus 3. W plus 1 will not cancel with w plus 2. So nothing canceled. Darn it. That's it. I'm done. Unless I have math wrong someplace. I don't think I do. I think we're good. Wow, that one was a lot. Okay, let's try number 8 and see where this one goes. My lowest common denominator for number 8. I've got an s. I've got an s squared minus 9. S squared minus 9 doesn't have an s in it, but I do need to recognize that as a difference of 2 squares. So that's going to be an s plus 3 and an s minus 3. When I look at the denominator, I have an s plus 3 already included. I have an s minus 3 already included. So my lowest common denominator is s plus 3, s minus 3. All righty, so if I rewrite this, I'm going to take a 2 over s minus 2 over s minus 3s plus 3. I'm going to factor that right away. All over 4 s plus 3 minus 4 s minus 3. Okay. Just like in the other steps. Now I'm going to multiply both the numerator and the denominator by s minus 3, s plus 3 over s minus 3, s plus 3. Okay. I need to remember this is in parentheses, this is in parentheses, and take one term at a time. Basically, this is just my big old giant 1, as was the one previously. Okay. All right. Let's take a look and see how we do. If I multiply all of this by the 2 over s, the s's will cancel. And I'll be left with 2 s minus 3, s plus 3, minus. If I multiply the second term by all of this, it is the s minus 3 and the s plus 3 that will cancel, leaving me a 2s. In the denominator, if I multiply all of this by the term 4 over s plus 3, it is the s plus 3's that will cancel, leaving us with 4s, s minus 3, minus 4 over s minus 3. It's the s minus 3's that will cancel, 4s, s plus 3. Okay, equals. Simplify. I know that s minus 3, s plus 3 was my s squared minus 9. So that will leave me 2s squared minus 18 minus 2s over. This will be a 4s squared minus 12s minus 4s squared minus 12s, right? Yeah, okay. So this will be a 2s squared minus 2s minus 18 over 4s squared minus 4s squared, knocking itself out, minus 12s minus 12s minus 24s. All right, can I factor anything? This is as simplified as I can get it. Can't add s's to s squares, two s's to 18s. This 24s, I was lucky. It did just, these guys zeroed out, leaving me just a 24s. So that's okay. Can I pull anything? I'm going to pull a 2 out of this top, and that's going to leave me s squared minus s minus 9 over a negative 24s. I can cancel the 2 and the 24. You need to remember that negative. The only thing I might possibly do is pull that negative up to the top. But this is one of those sort of iffy cases. Because if I pull that negative up to the top, then I've got to change all the signs on this, right? Just like we did before in the last section. If you pull that negative up, it's going to change the signs on everything. So this would be a negative s squared plus s plus 9 all over 12s. And I cannot simplify anything else. This is as far as I can go. For what it's worth, it also would have been perfectly fine to stop here. Oh, I didn't mention, did you check to see if this was factorable? You should, and I skipped over that part. 9 is only divisible by 9 and 1 and by 3. So the difference between 9 and 1 is 8, and the difference between 3 and 3 is 0. So turns out that this is not factorable, which is why I didn't mess with it. Sorry, my brain did it quickly and didn't explain. But this would not be factorable, so I would not factor it. And then the only other choice would be to pull that negative up. Okay? If you have any questions, please don't hesitate to reach out to me or to stop into the Math Center. Visit Julia and many of the other people who are currently helping her out there. Until then, take a deep breath. You got this. I'll see you next time.